Today on CodeDependent, I wanted to talk about color interpolation, which is a subject I usually avoid. I was interested in what kinds of color interpolation would be best to use by default in the next version of the Flex SDK, which is currently named Gumbo. So I had created effects that could handle arbitrary targets of arbitrary types, and given this capability, wouldn't it be nice if we had the ability to animate colors? So there's a new effect in there called FX Animate Color, and by default it uses RGB interpolation, which is better than what we had before, which is nothing. So you could do this stuff already, but it would just take more code. So now there's a built-in effect, and if you give it two RGB values, a start value and an end value, then it'll break the colors down into their RGB components. And it'll interpolate linearly between reds, between greens, and between blues, and then put the result back together into another uint or RGB color, and then you have your result. But there's other color spaces out there that can provide more intuitive results in some situations. So for instance, there's a color space called HSV, hue, saturation, and value. It's also called HSB, which is what I ended up calling it, hue, saturation, and brightness. And this is more intuitive for some people for selecting colors because we don't think of colors necessarily as being in this RGB cube. Instead, we may think of them in terms of the hue that they have, or how bright the color is, or how saturated that color is. And so I wanted to see how that interacted in an application. So first of all, let's take a look at how the colors actually work themselves, the color spaces. So if we go onto Wikipedia, it has some nice graphics for how to look at these things. So we can search for HSV. We actually don't want the herpes simplex virus item. Instead, we'll go into the HSV color space item. It's a little more appropriate. And they have a nice graphic here of the cylinder that you get with hue going around the ring itself. Value increases from the bottom, the black dark colors up to full-on brightness, and then saturation goes out to the full-on color from the less saturated white values in the middle. There's other visualizations of it here. This actually shows the values: saturation going out, hue going around, and value going up. So that's a nice way to sort of visualize how the colors work in this color space. RGB, on the other hand, has a color cube with green represented at one extreme, black at another, white opposite from that, and then we have blue and red over here, and then we have the secondary colors, cyan, magenta, and yellow in between those. And so if we're going to interpolate in these spaces, will we get a more intuitive interpolation in one color space versus the other? So I wrote two interpolators, the original RGB color interpolator, and then this new HSB hue, saturation, brightness interpolator, and then wrote an application to sort of visualize how this worked. So here's the simple application. We can interpolate between these two colors. We have a starting color of red and an ending color of blue, which we can choose in the color picker. We run it RGB interpolation, and as we run it over time, you can see that it basically goes through a dark magenta on the way, and it makes sense numerically, right? Red is represented by full-on red and no green and no blue components. So we're animating from that to full-on blue with no green and no red components. So over the time of the animation, since we're animating per component, the red will go down, the blue will come up, and they'll sort of meet in the middle, and we'll get this dark magenta color. Then red will keep going down, blue will come up, and then we end up at blue at the end. So we can see this again. We sort of animate through the dark magenta. Okay, that's okay, but can we do any better with HSB interpolation instead? So we run the same thing through HSB, and this interpolator basically takes the RGB start and end values and creates HSB representations of those, and then does linear interpolation between those components instead. So it's going to be linearly interpolating in value, in saturation, and in hue. And in this case, since we have full-on red and full-on blue, value is 1. It's going to be at the top of that cylinder. Saturation is 1. It's going to be at the outer ring of the cylinder. And then the hue is the only thing that changes, and we're going to basically be going around the cylinder. So let's see what this looks like in practice. So now, instead of going through a dark magenta, we actually go through a bright magenta. In fact, we see sort of a flashing artifact as we go through this really bright color on the way from the red to the blue. And it turns out that's not actually what we're after. So it was actually a good thing that we wrote the demo application to see what was going on. So we can pick some different colors. We can animate from green to blue. We can see if that looks any better. It's actually sort of reasonable up through cyan, but then again we get the flash as cyan dips down to this blue, and it's just really not the effect that we were looking for there. Green to red, we can sort of visualize these things, and it seems to go through these intermediate colors as it marches around the hue ring of the cylinder that have very little to do with what we want. So it turns out that HSB or HSV is very appropriate for choosing colors. They have much more in common with the way that we think about the brightness or the saturation of colors. But actually animating in HSB may not be the best thing for your situation, especially not as a general situation. I think we'll actually stick with RGB for now. It could be that if you're animating between colors that vary mostly in value or in saturation, that this would actually be a great interpolator to use. But for pure general case, we don't know what colors we're starting and ending on. Probably best stick to the RGB approach instead. So let's take a quick look at the code that actually makes this work. So this application has color pickers down at the bottom, and then this colored square in the middle. Again, as I said, this is gumbo code, so if you're coming from Flex 3, you may not recognize some of this stuff. So for instance, we have a rect defined here declaratively instead of actually needed to draw a flash object, flash graphics. So we have a rect defined with the solid color that is whatever color we're animating. And then we have the color pickers, the starting color and the ending color. Those define the colors that are used by the effects that are run. The effects are in this declarations block. We declare two interpolators, and this is where the actual mechanics of interpolating the colors works. These are with the SDK. You don't need to write the interpolators, but there's a very simple interpolator interface called iInterpolator if you want to write your own custom interpolator for your own custom targets. FX animate color will when you click on the left button, it'll run an RGB animation. So that's going to animate from the starting color to the ending color, and it's going to use the RGB interpolator to do so. The next effect here is the HSB. The only difference here is it's going to be using the HSB interpolator. And then finally, the default animation is going to be using whatever the default interpolator is, which we decided will stay at RGB interpolation for now. So when you click on the different buttons, it plays the appropriate animation. We can take a very quick look at interpolators. This is a new thing in Gumbo. The ability to animate arbitrary types means that we need the ability to actually ask you how to animate these things. So we can do so for some built-in types like numbers and colors using these interpolators. But if you have an object of some arbitrary type that we've never heard of, then we need to ask your code how to actually interpolate between two values of that type. So that's what this interface is about. There's a simple method that you override, simple function that you implement called interpolate. Given the fraction of the elapsed animation, the starting value that you started from, the ending value that you're going to, then you calculate an appropriate interpolation and return it. So in particular, if we're looking at the RGB interpolation, it implements the interpolate method. It takes the starting and the ending colors and breaks them down into their component pieces. So we have RGB channel information for the starting and the ending colors. We calculate the delta, and then we calculate a simple linear parametric equation that says, okay, well, these are the new RGB values, and then we combine those into the final RGB value. And similarly, we can take a look at the HSB interpolator, and that, again, takes the starting and the ending colors, except it actually converts those from RGB space into HSB space. It creates the delta values because it's going to be interpolating linear for saturation, which are values between 0 and 1, for value, which are values between 0 and 1, and for the angle, which is 0 to 360 for the hue. And then it'll do a simple parametric calculation to determine the final saturation and brightness and hue values, and then it will convert back into an RGB value. And that is the simple application. So RGB interpolation, better in general than HSB. I wouldn't defend that to the death, but certainly in my test cases that was the case. But HSB is also available, and general interpolation on arbitrary types is also available in Gumbo Effects. If you want the code for this application, other related stuff, check out my blog at graphics-geek.blogspot.com.